We shall discuss the principle of superposition and what is interference. Okay, that is the topic of discussion. At a particular point in the medium, the resultant displacement produced by a number of waves is the vector sum of the displacement produced by each of these waves. This we have studied in the 11th standard. Okay, whenever, say for example, this is the point and it is experiencing the displacement because of this wave, first wave, in the upper direction by say 3 centimeter. Then another wave which is reaching at this point simultaneously at the same time. Okay, and because of this second wave, say for example, this experiencing or rather this particle experiences 5 centimeter displacement in the upward direction. Now, provided, try to understand both the waves, first wave and second wave, are reaching simultaneously at this point, and individual displacements by first and second are 3 centimeter and 5 centimeter respectively, then this particle will have displacement is equal to 8 centimeter in upward direction. It is the vector sum. Now, if the another wave, say for example, this is the point where first wave is coming at any time, okay, and second wave is reaching at this particle and it is giving the displacement to this particle in downward direction, that is say 5 centimeter, and first wave is giving the displacement 3 centimeter in upper direction. Individually if they are incident, individually if they are reaching, then first wave is giving the 3 centimeter displacement in upward direction, and if the second wave is reaching individually in absence of the first wave, then it gives 5 centimeter displacement in downward direction. If both the waves, first and second, are reaching simultaneously at this point, then what will happen? This particle where these two waves are reaching will experience 2 centimeter displacement in downward direction. Try to understand. This is 5 centimeter downward, 3 centimeter upward, so resultant will be 2 centimeter in downward direction. So this part, if two waves are reaching at a point simultaneously, then the displacement of this particle is the resultant or rather vector sum of the displacement produced by each of the waves. The physical effect caused by the superposition of two or more than two waves at a particular point in the medium is the interference. Now there are two types of interference. First is constructive interference, when crest of one wave superposes on crest of the other wave. Then when trough of one wave superposes on trough of the other wave, then such resultant interference is called the constructive interference. Crest superposes on crest of other and trough superposes on trough of the other, then this is a constructive interference. Now destructive interference, when crest of one wave superpose on trough of the other wave, or when trough of one wave is superposing on the crest of the other wave, then it is a destructive interference. Now explain the superposition principle for wave forming in the calm water. Figure shows that two needles of equal phase oscillating represents two coherent sources. Coherent sources means the sources which are oscillating with the same phase or phase difference between the two sources remains constant, then the sources are said to be the coherent sources. So these are the two needles which are oscillating up and down in the calm water. Okay, Now what will happen? Whenever both the needles fall in the water simultaneously, both will fall in the water or both will be inserted in the water simultaneously, then both will produce the disturbance in the water simultaneously and the waves will be generated. Okay. Now we consider two needles moving perpendicularly up and down in the identical fashion. Okay. At a particular point, the phase difference between the displacement produced by each of these waves does not change because they are the coherent sources. Now this figure B, which is given here, that is giving you the idea at any point of time what is there in the medium. Okay, these are the 2 points where there is a origin of the wave. Okay, the needle is moving up and down in the wave and producing the disturbance, and these disturbances will propagate in the medium, okay, in different direction. Okay, and they will experience the superposition, or we can say these disturbances will experience the superposition. Now consider a point P in this figure, okay, that is in figure number A. Try to understand this figure. This is the point P which we are considering. Okay, now this distance of this P from first source, that is S1, and the second source S2 is same, that is S1P is equal to S2P. Since wave from S1 and S2 will take the same time to travel to the point P, okay, then they will be moving at the same phase, or we can say the two waves are reaching at point P are in phase, or phase difference will not be there, or if there is a phase difference then that is going to remain constant. The displacement of distance produced by the source at point P is given by S1, okay, or we can say displacement which is produced at S1 source. The displacement, we have the wave equation that we have studied in the 11th standard, okay, that is y1 is equal to a cos omega t, because both the waves are having, or rather both the pins are moving with the same phase, okay, and they are going inside the water in a same amount, so the displacement, rather amplitude of both the waves will also be same. So y1 is equal to a cos omega t, y2 is also a cos omega t, a is the amplitude. Now superposition principle, if you take, then y1 plus y2 it will become, so it becomes 2a cos omega t. Okay, this principle we have studied. Now intensity of light is proportional to the square of amplitude. This we know. This is also studied by us in 11th standard. Intensity is directly proportional to the square of amplitude. Okay. Now intensity produced by each one of the individual source is I0, then I0 is proportional to square of amplitude, so individual intensity I0 proportional to the A square. Now resultant wave at point P has amplitude 2A, so resultant wave which is superposed will have intensity at point P which is I is proportional to 2a square, where 2a is the amplitude now. Okay. Now if you take the ratio of I to I0, I upon I0 if you take, then it will become 4a square upon a square. Or we can say the new intensity will be 4 times the original intensity, and this is for the constructive interference when the crest and crest, trough and trough are superposed. Okay, if there is a destructive interference, then the displacement of particle at point P by one wave will be in one direction, and the displacement by the other wave will be in the opposite direction. Try to understand. One is moving in upward direction, or we can say the displacement due to one wave is in upward direction, then the displacement by the other wave will be in downward direction. So resultant displacement will be 0 because these two waves are having the same amplitude and they are in phase. Okay, so y is equal to y1 minus y2 it will become, and y is equal to 0. Therefore, resultant intensity at this point P will be 0, and you will have the destructive interference.